Alright, so let's figure out how to use Pythagorean theorem. So the first question is, what do you use it for? Two main approaches you'll be seeing. How to find the missing side of a right triangle, and then how to check if a triangle is a right triangle. That'll be the converse of the Pythagorean. Now, here's a basic example. You have a right triangle. One side's 6, one side is 8, and the other side is missing. So what you're going to start with is you're going to label your triangle ABC. So A and B are going to be the legs, the shorter sides, so that's what I'll label 6 and 8. And then the missing side is my longest side, so that's C, the hypotenuse. Now, what I'm going to do is I'm going to use the Pythagorean theorem, A squared plus B squared equals C squared, and I'll just replace what I know. So I know 6 squared plus 8 squared, and that's equal to C squared. So you'll solve that. Now, if you go type into the calculator, what is 6 squared plus 8 squared? And I'll get 100. Now, 100 is equal to C squared, and the final step is always to do square root. So what's the square root of 100? You should find out that that is 10. So in this example, C is equal to 10. Don't forget to check that C is always the longest side, the hypotenuse, and in this case 10 is the longest side. Now here's the other version of this example. You have a triangle with all three sides. So in this case 5, 12, 13. So you're not solving a missing side here. You're going to check, is this a right triangle? And so what we'll do is we'll use the Pythagorean theorem and we'll sub in what we know. Now again, remember, notice how I labeled A, B, C. A, B are the shorter sides and C is the longest side. So is A squared plus B squared equal to C squared in this case? Well, is 5 squared plus 12 squared equal to 13 squared? So let's go check. What's 5 squared plus 12 squared? And I get 169. So is 169 equal to 13 squared? And when I check that, I also get 169. So in this example, is A squared plus B squared equal to C squared? Yes. So this is true. It is a right triangle. And those are the two types you're going to see. Now, I'm going to go over some trickier problems they may come across. Let's make sure we understand what's going on. Alright, so the basic idea here is when you're solving the Pythagorean theorem is if you have legs, you're going to be adding. But if you have the hypotenuse, you're going to be subtracting. So on this first example, let's go ahead and set up what we know. So what do we know? What do we have? Well, if you go label it, you'll know that you'll have A and B, and you're missing side C. So label A and B, and since A and B are the legs, you're going to be adding. So 9 squared plus 12 squared is equal to C squared. Solve it. What's 9 squared plus 12 squared? And I get 225. Now, final step, square root. So what's the square root of 225? And you get 15. So in this case, side C is 15. And don't forget to check that the longest side is the biggest number. And in this case it is, so I know I'm good. Now, something I want to mention there is there's a few other approaches. Some people like type this into the calculator, and you can. So starting from here, this could actually have been typed in. So if you go to Math Solver, you can type in that equation. So I'll type in 9 squared plus 12 squared, and that is equal to C squared. So notice you can actually type in C squared. Now keep in mind that when you set it up, the boxes kind of form on both sides of the equation. So that's how I know what to put where. Now, on your calculator, you'll go ahead and scroll down and always double check that this equation here matches the equation we're trying to solve over here. A lot of people type it in wrong and you run into issues. So if I solve for C, I'll get 15, which is what I knew I was going to get. It's just showing you that there's a method that you show your work, and then over here you have your calculator. So if I set up the next one, notice what I gave you this time. This time I gave you 13, which is side C, the hypotenuse. Notice it's the longest side and it's opposite the right angle. So what do you do when I give you the hypotenuse now? In this case, you're going to subtract. So what is 13 squared minus 5 squared? And that's equal to b squared. So if I go set this up, what is 13 squared minus 5 squared? And you'll end up with 144. Okay. And final step, square root. So what's the square root of 144? And you get 12. So b is equal to 12. And then of course, if you want to use solver or if you want to type it in all together, this tends to be one of my preferences once you've practiced a lot. So long as you know when you're adding and subtracting, you can type it in one clean step. Alright, now let's take a look at something like this. So if you have something like this, notice it's still a right triangle, and I'm still asking for the missing side, except this 576. That's not a number you're used to seeing there. The reason is it's an area. So how do you handle this if I give you an area? Well, you still want to label. And so for example, I know the 7 is also there on the side of the triangle because it's a square and all sides are equal. Now what I'm simply going to do here is, if the area of the square is 576, then the square root of that. And what is the square root of 576? 24. 24 represents the sides of the square. So I actually can solve this as I normally would. Find side C, given that you have the legs A and B. And if I give you the legs, you will add. So what's 7 squared plus 24 squared equal to C squared? So what's 7 squared? Type that in. Plus 24 squared. You get 625. And then don't forget your last step, square root. So what's the square root of 625? And you get 25. So side C is 25. There you go. Now, some people get freaked out by some examples like this as well. Notice there's a slight difference, nothing too crazy. But you treat it as any problem. Label what you have. I have side C, the hypotenuse, and square root of 17, one of my legs. If I give it the hypotenuse, you will subtract. Now notice how I set up my subtraction. 9 squared minus the square root of 17 squared. As you get better in your math and algebra, you'll see other tricks to this, but for right now, you solve it as you set it up. So what is 9 squared minus the square root of 17 squared? Notice how I'll move out just to get it typed in the exact same way. And I get 64. So 64 is equal to b squared, and my last step is square root. So what's the square root of 64? And I get 8. So my missing side is 8. There you go. And let's try one more example that you may come across. Diagonal. So this is a popular keyword for Pythagorean Theorem. What is the diagonal? Now, Pythagorean Theorem keywords could be distance, diagonal. The most popular is a picture of a right triangle. But I don't have a right triangle here. Or do I? Well, when I ask for the length of zx, that forms a diagonal. So the diagonal is a hint. Now, when I make a diagonal in my picture, you can actually see the right triangle. And all I know is that one of these sides is 12, but it's a square. So if I'm looking for the diagonal, my hypotenuse here, what are my legs? They're 12. All sides are the same. And if I give you the legs, you'll add, and you'll work that out. Now, remember the different approaches you can take. I like to just type it in like this. The square root of 12 squared plus 12 squared. And that takes me straight to my answer. But if you want to type it in one piece at a time, you could do 12 squared plus 12 squared. And I get 288. And then I'll just finish off the step. My last step is the square root. So what's the square root of 288? And there you go. So my answer would be, to the nearest tenth, it rounds actually up to 17. And I'll change it to approximately. So this was your refresh on Pythagorean theorem.